Hello everyone, this is Subham Nanda of Madras Public School Puri, here in front of you to share my experience regarding the teaching of our respected sir. Basically, sir was my math teacher during class 9 and 10 in St. Xavier High School Puri. He teaches in a very simplified manner that makes the fear of math out of the mind and makes the children fall in interest with mathematics. Mathematics is a very conceptual subject that is not so hard. If you clear your concepts, then you can solve each and every questions of the subject and score very good marks in the examinations. Sir always clear the doubts of the children when they approach him during his free time. He always teaches in a very cheerful manner and makes clear each and every concept of the topic of each and every chapter of the book. He is not in a hurry mood to complete the course. He teaches in a slow and steady rate. He also takes extra class for clearing the doubts and giving extra questions. He starts from the basic level and goes to a high level that can be understood by a low level, by an average level, and also by a high level student. First of all, he advises us to solve each and every question of NCERT so that you can clear your concepts. Then you go for the very high level questions. Sir also gives us very extra high level questions that is not only beneficial for the school level but also some extra competitive examinations during class 9 and 10. After the completion of each chapter, sir conducts a class test which makes the student realize about his progress in the current scenario. After a long request of the students, sir has come to this online platform to help students during this pandemic situation who are not able to attend the online classes, cannot clear their concepts. They can watch the videos of sir in YouTube and clear their concepts. I am very happy to tell that under the perfect guidance of sir, I was able to score 100 out of 100 in mathematics in the class 10 board examinations. So it is a very golden opportunities for the children who have a interest in mathematics so that they can clear their concepts and score very good marks in the examination. This is really a very extra edge for the students in this situation where classes are not going on properly. They have some network issues. Sir has 20 years long experience of teaching in the CBSE's curriculum schools. So he knew from which topic the questions can come, the twisted questions that can come in the examinations. So he always give us every variety of questions that can be asked in the examinations and also in many other exams that are beneficial for us. So I can tell that sir is one of the most talented and most experienced teacher in this current scenario. So it is very good and a golden opportunity for the students to learn under his guidance and clear your concepts and become a genius in mathematics. So his long years of teaching had made him called a giant in mathematics. Thank you, sir.
Hello, dear students. In my last class, I discussed about the distance formula and how to find the distance between a point from origin. Now, I am going to discuss the applications of distance formula. How you apply the distance formula, in which case you apply the distance formula, and when you apply the distance formula. Now I am going to discuss the pattern of questions one by one. So the first pattern of question: if a point, the distance between P2 minus 3 and Q10y is 10 units. Suppose the distance between, it is given that the distance between P and Q is 10 units. How you find the value of y? In this case, we know that according to distance formula, PQ is equal to root over of 10 minus 2, that is 8 square, plus y minus 3, that is y plus 3 whole square. PQ is equal to this one, but it is given that PQ is equal to 10. Implies that root over of 8 square plus y plus 3 whole square is equal to 10. So to remove this square root, we square the both sides. Implies that 8 square plus y plus 3 whole square is equal to 100. 10 square 100. Now this is a quadratic equation. We will solve it. After solving it, we will get the value of y. Here two values of y will come. One is positive, one is negative, or two may be negative. So after solving this quadratic equation, means 64 plus y square plus 6y plus 9 is equal to 100. This follows a plus b whole square. Then this becomes y square plus 6y minus 64 plus 9, that is 73. 73 minus 100, that is minus 27 is equal to 0. You factorize it, you will get the two values of y. This is the first pattern. Now comes to the second pattern in which you will apply the distance formula, that is called type 2. Type 2. In type 2, it is given that if, suppose this type of question will come, if pxy is equidistant from 7, 1 and 3, 5, then here the question will come, if pxy is equidistant. Equidistant means p, that is, let these points are q and r. Equidistant means pq is equal to pr. So we have to find the condition here. Condition, or it is given to prove. So whatever it may be, PQ is, as it is equidistance, PQ is equal to PR, implies that PQ square both the sides to remove the square root, implies that x minus 7 whole square plus y minus 1 whole square is equal to x minus 3 whole square plus y minus 5 whole square. Here you will get x square minus 14x plus 49 plus y square minus 2y plus 1 is equal to x square minus 6x plus 9 plus y square minus 10y plus 25. This is. So here x square cancel, y square cancel, and by solving this one, simplifying this one, you will get a linear equation in two variables. That linear equation in two variables is called the condition. Then comes to type 3. In type 3, we know that in my first class I told you that any point on x-axis having y coordinate 0, any point on y-axis having x coordinate 0. So type 3 relates to the same. You have to find out a point on x-axis. Find a point on x-axis. Point on x-axis which is equidistant from 2 points, any two given points. Suppose 2 minus 5 and minus 2, 9. It is said to find the coordinate of, or the coordinate of the point which is on x-axis. If let P is a point on x-axis which is equidistant from Q and R, as it is a point on x-axis, you will take it as x0, because I told you that any point on x-axis having y coordinate 0. So now the condition is PQ is equal to PR, implies that PQ square is equal to PR square. Then apply the distance formula, simplify it, you will get the value of x. Now if the point is on y-axis, instead of x-axis if the point is on y-axis. Then you have to take the point as 0y. You have to take the point as 0y because any point on y-axis having x coordinate 0. So then you go for simplifying it. These three are relates to equidistant. The first one relates to direct distance one. Then comes to the condition of collinearity. This is type 5. Condition of collinearity. We know that three or more points are collinear if they all lie on a straight line. Now I am going to give you three lines here. In where A, B, C are three collinear points. Where A, B, C are three collinear points. What you learn from it? Now B, C and A are the between points between other two points. B, C and A are called the between points. So here AB plus BC is equal to AC. Here AC plus BC is equal to AB. Here AB plus AC is equal to BC. That means the sum of two parts is equal to the third part. If in any line 3 points are there, anywhere 3 points are there, and through 3 points we join a line, and the sum of any two parts is equal to the distance between the two endpoints, then the 3 points are collinear. Any one condition among these three will satisfy, then it is called collinear points. Now comes to an example. You have to show that 1, 5, 2, 4 and 3, 3 are collinear points. Let the points are A, B and C. A, B and C. Now first find AB by applying distance formula. Root over of 2 minus 1, 1 square, plus 4 minus 1, 4 minus 5, minus 1 whole square, that is root 2. BC is equal to 3 minus 2, 1 square, plus 3 minus 4, minus 1 whole square, that is also root 2. Now comes to AC, 3 minus 1, 2 square, plus 3 minus 5, minus 2 whole square, that is equal to 8, root over of 8, which is equal to 2 root 2. Now we get the length of three parts. One is AB, BC and AC. Here root 2 plus root 2 is equal to 2 root 2. Implies that AB plus BC is equal to AC. As the sum of any two parts, I told you the sum of any two parts is equal to the third part, then they are collinear. Here we get the sum of AB and BC is equal to AC. So ABC are three collinear points. Now comes to type 6. In type 6, we know how to classify the triangles. How to classify the triangles using the distance formula. Distance formula tells you the length of sides. So with respect to the length of the sides, how we classify the triangles? As we know that the triangles can be classified as scalene triangle, number 2 isosceles triangle, number 3 equilateral triangle, Number 4, right angled isosceles triangle. Right angled isosceles triangle. With respect to measurement of length of sides, we can classify triangle into 4 types. One is Colline, isosceles, equilateral and right angle. Suppose in this type, 3 vertices will be given to you. A triangle has 3 vertices, the coordinates of 3 vertices will be given to you. You have to find out which type of triangle is it. Or in some questions it is given to prove. Prove that these vertices are the vertices of a right angle isosceles triangle. Then how you do it? See here. First, you are having 3 vertices. Name it as ABC. This is given in your question. Clear? After writing the vertices, find the sides. That is your first duty. By applying distance formula, find AB, find BC, find AC. After finding AB, BC and AC, now go for testing. Number 1. If no two sides are equal, that means AB is not equal to BC, is not equal to AC. Then the triangle is a Scalene triangle. Number 2, if any two sides are equal, either AB is equal to BC, or BC is equal to AC, or AC is equal to AB, then it is an isosceles triangle. Number 3, if all sides are equal, AB is equal to BC is equal to AC, then it is an equilateral triangle. And the fourth one is, as it is right angle isosceles, we can measure the angle, but we can test it by using Pythagoras Theorem. How you use it, Pythagoras Theorem? Now observe, if any two sides are equal, either AB is equal to AC, or BC is equal to AC, or AB is equal to AC. After observing any two sides equal, then go for testing. Suppose AB is equal to AC. Now it is isosceles. How to prove it is right angle? Now if sum of the square of two equal sides, that means AB square plus BC square, if sum of the square of the two equal sides is equal to the square of the third side, then it is called right angle isosceles triangle. So now take it. Triangles can be classified as Scalene, isosceles, equilateral, right angle isosceles. You are given 3 vertices. You have to show it which type of triangle is it. So first you have to find out the 3 sides AB, BC, AC. Then go on comparing the sides. If no two sides are equal, then it is Scalene. If any two sides are equal, then it is isosceles. If all sides are equal, then it is then it is equilateral. If two sides equal and sum of the square of the two equal sides is equal to the square of the third side, then it is right angle isosceles triangle. So what will happen? Now we discuss it with the help of an example. Let us take an example. Suppose you are given that prove that A30, B64, C -1, 3 are the vertices of a right angle isosceles triangle. So I told you, first find the sides AB, AB is equal to 6 minus 3 square plus 4 minus 0 4 square, that is equal to root over of 25, that is equal to 5. Now comes to BC, minus 1 minus 6 minus 5 whole square plus 3 minus 4 minus 1 minus 6 minus 7 whole square plus 3 minus 4 minus 1 whole square, that is equal to root over of 50. Then AC, minus 1 minus 3 minus 4 whole square plus 3 minus 0 whole square, that is equal to 5. Now as AB is equal to AC, it is isosceles. Then to go for testing right angle, I told you that the sum of square of the two equal sides, that means AB square plus AC square is equal to 5 square plus 5 square is equal to 50. Now is equal to the third side. What is the third side here? BC. Square of the third side, that is root 50 whole square is equal to 50. Now what we get? Now AB square plus AC square is equal to BC square, and AB is equal to AC. As two sides are equal, it is isosceles. As it follows the Pythagoras theorem, it is right angle, so it is right angle isosceles triangle. Now the last type is how we classify the quadrilaterals. How we classify the quadrilaterals with according to their length of sides and diagonals. Classifying quadrilaterals. Classifying quadrilaterals. See here, the following quadrilaterals can be classified with respect to the length of the sides. First, parallelogram. Second, rhombus. Third, rectangle. Fourth, square. Fourth, square. Like the classification of triangles, here 4 vertices of the quadrilateral will be given to you. Suppose ABC are 4 vertices of a quadrilateral which is given to you. You have to classify the quadrilaterals. The vertices, these vertices are vertices of which type of quadrilateral? I told you that this is the application of distance formula, always apply distance formula. Suppose the quadrilateral is like this. I want to classify it. I am having 4 vertices given. So, if opposite sides are equal, after finding the length of sides, your work is, first work is find AB, find BC, find a CD, find DA. These are the sides. Again, find the diagonals AC and BD. These 6 you have to find out first. This is the first duty of yours. Then, after finding it, after finding this one, you have to compare the sides. You have to compare the sides. If opposite sides are equal, if you observe that the opposite sides are equal, that means AB is equal to DC, BC is equal to AD. Opposite sides equal means their lengths are equal. Then it is a parallelogram. So, number 1, if AB is equal to DC, BC is equal to AD, then it is a parallelogram. Number 2, if all sides are equal, that means AB is equal to BC is equal to CD is equal to AD, then it is a rhombus. Number 3, if opposite sides equal, AB is equal to BC, BC is equal to AD, and another additional one, AC is equal to BD, the diagonals are equal. Opposite sides equal, diagonals are equal, then it is a rectangle. Number 4, if all sides are equal and diagonals are equal, then it is a square. So, actually, there is no difficulties to find the distance between any 2 points or the length of the sides. After finding the length of the sides, you can verify or you can prove any type of quadrilaterals. The process is like this. 4 vertices will be given to you. Either it is to prove or to classify the quadrilaterals. So first, your work is first, if it is given parallelogram or rhombus, no need to find the diagonals. Only you can compare the 4 sides so that you will get parallelogram or rhombus. Then, if it is given either rectangle or square, then you have to find out the AC is equal to AC and BB. This is number 1. If classification is given, this is in proof. If classification is given, then at that time you have to find out these 6, so that you can tell whether it is parallelogram or rhombus or rectangle or square. This is all you can find out by applying distance formula. So I thought that the distance formula and its application, these are the applications of distance formula. The distance formula and its application, you can easily solve your problems given in NCERT, as well as any problem comes from anywhere else, to prepare yourself for board exam. Thank you. So, to be regular in touch with me, to clear your concept, do like, comment, share and subscribe our channel, that is Invariant Maths. Thank you.